Hello, listeners, and welcome to Capital Root -1 FM with your host, your maths older brother, Mr. Raz, MC Raz on the mic. So, one of our listeners today has said he's having problems with quadratic simultaneous equations. Apparently, his teacher's has been a bit insensitive to his needs, and so we're going to deal with that today. Just show off the graphics first. Yeah, I'm actually trying to push for sponsorship from Smartboard, so it's not worth going down so well at the moment, but fingers crossed. So, here's quadratic simultaneous equation. Now, what's the difference between this and the regular linear simultaneous equations? Any viewers out there? That's exactly it. The function in blue is a curve, a horseshoe curve, and the red one is a straight line. Yeah, so we have here a curve and a line, and they're meeting. And when we solve that, we find the points at which they meet. So the first step to do this is we have to set these equations equal to one another. Why is that? Exactly, because we want to get rid of one of the letters. And I say that we're eliminating a variable when we do that. So we set these equations equal to each other, and you notice the y has gone. Yeah, so the reason to do that is we're trying to get rid of a letter. We know if y equals x squared plus 11x plus 25, and y is also equal to 2x plus 5, then it is fair to say that x squared plus 11x plus 25 must also equal 2x plus 5. And now in a position where we only have one unknown, we can solve it. Now, if the highest power is 2 on one of the x's, what sort of equation is it? Exactly. It's x squared. How do we solve? That didn't even make sense, did it? Not exactly it's x squared. Exactly, it's a quadratic. So how do we solve a quadratic? We set it equal to 0. Yeah, so whenever you have a quadratic, you put the x, group the x squared terms, then the x, and then the number. And we need to make sure it's equal to 0 to solve it. So if we move the 2x to the left-hand side and the 5 to the left-hand side, you'll see we get x squared plus 9x plus 20, and that's where we'll take it on the next page. So we need to solve... we need to solve the yellow box. So what are our options here? Any listeners want to suggest? Our first viewer, yes. Exactly, that is right. We can factorize or we can use the quadratic formula. So in this, all the ones that we're doing today, including the questions that I'll leave you that joins the examples classes, you can solve all of them by factorizing. You will not need the quadratic formula, but this links well with the quadratic formula. You can check that out on one of my other videos. Yeah, just go onto the website and you'll find it there. But here, well, that wasn't as smooth as I was hoping. We can factorize x squared plus 9x plus 20 to x plus 5x plus 4. Again, if you're not sure of where I got that from, you can go to factorizing quadratics on the website, and there'll be a video there with me explaining it. Once we factorized it, we'll see that the solutions are -5 and -4. Yeah, so we're looking at it and we're thinking, what values can x be for that bracket to equal 0? Well, -5 plus 5 is 0. And what values can x be for the second bracket to equal 0? So -4. So we get two solutions that are -5 and -4. Now let's pretend that those arrows have nicely faded in now, and they're pointing at that x. That's because I need to substitute the values back into either one of the formulas to figure out why. Now, why do I pick the red box and not the blue box? Exactly. It's spot on. You're on fire today. Because it's easier. Why would I sub into x squared plus 11 when I can just, there's a times it by 2 thing there. So if I sub it into the red equation, what is 2 times minus 5? Minus 10. What is minus 10 plus 5? Minus 5. So when x is minus 1, y is minus 5. So then I substitute x is minus 4 into the red equation. Yeah, where the box is. I just shove it in there. So I have to do 2 times minus 4, which is minus 8. And minus 8 plus 5 is then minus 3, which means when x is minus 4, y is minus 3. So what we have found is coordinates. So if you imagine the horseshoe and the line, they cross at the points minus 5, minus 5, and minus 4, minus 3. Yeah, so a curve can be intersected by a straight line twice. So make a note of what you've seen and then answer the questions. But before that, also I have the summary page. So this isn't the smoothest lesson today, but it is late night and I'm your bigger brother here. Big brother maths. I'm helping you out. So here's the summary. So what did we do? We eliminated a variable. How did we do that? We substituted the equations equal to each other. Then what did we do? We grouped the terms and we set it equal to 0. And then we solve it. Yeah? So in these topics, I'm assuming you're fine once we get to solve. If you're not, then you need to either go to the quadratic formula video or the factorizing quadratics video. So at this point, you can pause the video. Yeah, and when you can answer these questions, the solutions will not be on the next part. They'll be on the examples video, which again on the on my website under the quadratics, there's always a lesson and then there's some examples. You just go to the example ones and it will be there and it links to my YouTube channel. So we had a horseshoe and a straight line in the previous example. Now we have a circle and a straight line. How do I know? How does that purple equation differ to the one we had previously? No? No one? No. So we've got an x squared and a y squared. So whenever we have an x squared and a y squared, we know the shape will be a circle. Yeah. And at GCSE, these circles will always have a center of 0, 0. So again, a circle and a straight line could intersect twice. Yeah. And that's why we end up with 2 solutions often. So this time, to eliminate a variable, we find y squared. Yeah, so if I look at the purple equation, there's a y squared there, and I want to get rid of it. I want to get rid of one of the letters. But unlike previously, it's not a y. So we don't start squaring things and square rooting. So we don't start square rooting the purple equation. We square the blue one. What does squaring mean? Exactly, times by itself. So we have to do x minus 3 times... Oh, it's happened again. We have to do x minus 3 times x minus 3. Maybe this is why they won't give me my sponsorship. So, go away. So, there's y squared. Yeah, x minus 3 times x minus 3. And that gives us, when we expand it with FOIL, first outer inner last, we get x squared minus 6x plus 9. So it's that we're going to substitute into the purple equation, where the red box is, to eliminate the y. Yeah, so instead of writing y squared, because I know y squared is x squared minus 6x plus 9, instead of writing it y squared, I'm going to write x squared minus 6x plus 9. Like so. Yeah? What sort of equation is this? Exactly, it's quadratic. How do we know it's quadratic? Well done, because the highest power of x is squared. Yeah, so then what we do when we have a quadratic equation, we group the terms and set it equal to 0. Now, at this point in an exam, there's a high chance you need the quadratic formula here, but for this video, they all drop out nicely. So if we were using a formula, A would be 2, B would be -6, and C would be -20. We don't need the formula because we can see there's a common factor there of 2, so we can halve everything. We halve everything, we get this, and that will factorise as so. Once we factorised it, we know x must be 5 and x is -2. So we've got x is 5, x is -2, but what are we trying to do? We're trying to see where the purple line and the blue line coexist, i.e. where they're the same, where they share values. So that means the y values must be the same. So if I sub the yellow into the blue, I will get 2 and -5 because, so when x is 5, 5 take away 3 is 2. And when x is -2, -2 minus 3 is -5. Yeah, so if I subbed into the purple equation, I'll get the same answers. It's just not worth the hassle. Yeah, if I try it with x is 5, 5 squared is 25. 25 take away 29 take away 25 is 4, and the square root of 4 is 2. So you get the same answer, it's just not worth the hassle. Yeah, it's much easier subbing into the blue one. So that means we have found where the circle and the line intersect. So they intersect or meet at the coordinates 5, -2, and 2, -5. Yeah, so we summarize. We have eliminated a variable by finding y squared. Yes, remember we took the blue equation and we multiplied it by itself. So we did x -3 times x -3. We then substituted that into the first equation to get rid of the y, or y squared. So we eliminated a variable. We grouped the terms and set it equal to 0, so we were able to solve the quadratic formula, and that was it, yeah? So we grouped the terms and we solved it. If you're not sure of anything here, just rewind and play it back and read through it step by step. And try these questions, please. Yeah, good luck. You can catch the solutions on the examples part of this on my website. Yeah, good luck. Raz out.